Okay, welcome to lesson 2 on speed, and today we're going to look at can we understand and use distance time graphs. Now this lesson is a double on paper, but today it's going to be a single. It'll mean that tomorrow's single will be ever so slightly longer. Okay, so apologies for that, but it's just the way that these lessons have fallen. So I want you to have a look at these and tell me, what are these graphs telling you? So have a pause, have a think. What are they telling you about speed? Okay, so we have 3 graphs here. So graph A, what's happening to the line? Is you increase the temperature, the distance is increasing. So in this particular graph, we say speed is increasing. In graph B, what's happening to the line? The line is now going down. So as you increase time, you decrease distance. So here, speed is decreasing. And in our last graph, graph C, what's happening to the line? It's staying in a straight line, so speed is what is called constant. Pause now if you need to. Your title is the distance and time graphs, and please make a note of what each line is telling you because you're going to need it when you move forward. Now these are graphs. Time on your x-axis, so the thing that changes versus the thing that you measure. You will have situations where you are going to have to plot the points and then do some of the maths, and in other scenarios they're going to give you the graph like this and you have to decide some stuff. So we're going to look up here first, and question is, how long does it take for B to travel 11 meters? So in this instance you have to decide, what the hell is 11 meters? Is it a distance or a time? And it is a distance, and this is where 11 meters is. And to figure out the time, we go for a little walk. And when we hit our B, because it's B that we're interested in, when we hit the axis, so at this point here, we drop down. So on this particular graph, we can see that at 11 meters, it's taken 5.5 seconds to get there. In our second question, how far has each walker walked in 2.5 seconds? So again, you have to decide, is this a distance or a time? It's seconds, so it's a time. So you find where 2.5 lives, which is here, and then you go up. So when I hit B, I'm hitting it here, and I go across to find the distance traveled, so that it works out at 5. And I also continue on for A and work across, and this is about 7.5 meters. So you're using the graph, you've got one part of two things, and you're using the graph to find the other. Is the speed of each walker constant? How can you tell? So if it looks like it is doubling as it goes up, it's one straight diagonal line and there's no change to it, that's telling you that their speed is constant. If this line went up and it got to here and it went way up here, well, their speed has now changed at this point. So the speed is constant, and how can you tell? Because it is one diagonal line, the slope is not changing. What is the speed of person A and person B? So this is a new thing for us to work out. So obviously if you were in the class, I'd ask you, have you done slope in maths? So the slope in maths tables, if you look at it, it'll be this m. There's an equation of the line in maths, and m, well, is in this particular equation, but we're only interested in the slope. So the slope is essentially rise over run, it's called. Okay, but in math speak it is y2 minus y1 over x2 minus x1, and you have to, for each thing, come up with the point. So my suggestion is, because this graph runs through 0, 0, you can make this point down here x1, y1. So essentially you're going to be putting 0 into this part of your equation, which means you can forget about it. And I would always suggest taking your end point to be y2, x2 and y2. Okay, so you find what x is, just like we found the other pieces of information earlier. So it's going to look like this for you. So the slope of A is going to be y2 minus divided by x2, because this is 0, 0. So up here you will see, you do your whole line across, you do your whole line down. Oop, apologies for the swirly bits. So here my y is 21, my x is 7. 21 divided by 7 gives me a slope of 3 meters per second for there. So you're going to pause and you're going to see now, can you do this same piece of maths on B for me? Okay, so I am hoping that when you did B, again, you can ignore 0, 0, but you found that the top point in B up here was 14 for y and 7 for x. But when you do that piece of maths, it is 2 meters per second. So we're going to have a practice with some graphs now, some questions. So away we go. So you have this particular graph, calculate the speed. Pause and come back to me. Alrighty, so now that you've done that, again, we can ignore down here because it's 0, 0, it starts, so it's perfect. So we go up to our top point up here, and our top point is 8 for x, 40 for y, so 40 divided by 8 gives me a speed for this particular graph of 5 meters per second. Now, your homework is going to be on the next slide. There's 2 parts to it, or 3 parts to it, so please bear with me. Okay, so there's a PDF document attached. It contains what is called a spiral crossword. So there are 8 clues for this crossword, and the answers are all numbers. Answer 1, you can see the line has 2 numbers in it. Answer 2 has 2 numbers. Answer 3, 3 numbers. Answer 4, 3 numbers. 5 is 1 number. 6 is 3 numbers. 7 is 2 numbers. 8 is 3 numbers. Okay, so you've got to do your piece of maths and then fill them in. And there is 1 exam question. You may have to plot the graph yourself if you can't print. Do the best you can. And RAG sheet is about to follow, and you need to annotate your notes for RAG statement number 4.